This is GUI developed for digital watermarking using fingerprint features as a digital watermark. The objective of the work is processing a fingerprint features, fingerprint image, and extracting features which will be used as a digital watermark for watermarking audio signals and image. So this is the first module, which gives you an option for generating the watermark and seeing the perspective density of the watermark. The second module is related to image watermarking, where the various options are given, and the third one is the audio watermarking, where various options are given for generation, for embedding watermark, applying attacks, and extraction of the watermark under attack conditions. So here we go, and we first we select a fingerprint image. Let's say we go from here. Let's say we select one of the one of the images from the database. Let's say I select this one, the first one. So the image is selected over here. Now this biometric watermark generated, if I click this, the entire process is done to extract the features from the image and generate a template which will serve as the watermark for watermarking the images and the audio signals. And feature extraction is relatively a time-taking process, so it may take a while to generate the template. So here we see the status bar is indicating that the task is under process, and once it gets completed, the messages will come up. So the message says the digital watermark is generated from a selected fingerprint image. So I OK this and show the feature points of the selected image. Let's see how it goes. So you can see the minutiae points which are there in the image is indicated in this figure, and this will be used as a watermark. And here, once we extract the watermark from the signal under attack conditions, the minutiae points will be matched for actual identification. Let's see how the PSD of the watermarks look like. Well, you can see that the perspective density of the watermark seems to be uniformly distributed throughout the spectrum, because it's normalized frequency. One is the maximum frequency, and here in perspective magnitude in the y-axis, it indicates that there is equal distribution of the spectrum across the magnitude. So also there's an option to see how many watermark bits are there. Let's click this. So it indicates that 9600 is the number of watermark bits generated, which is generated from the template of this fingerprint. So you can see 9600 is a fairly large data which to be used as a watermark, and hence to hide this watermark in an image or audio, considerable amount of payload will be necessary, and proper watermarking method is necessary to cater to that much of payload conditions. Come to the module, this module, where the module is image watermarking. You can see this option will give you to choose a host image. So here we go. So once clicking here, we need to calculate one of the we need to select one of the images. I select this image Lena, and hence now this button will give you the option to embed the watermark in the image. So the embedding process is on. So once the embedding process will be done, this status bar will indicate. So here you go, and you can see that the process may take some time because it's a block-wise process, and the entire image is divided into blocks, and every block is processed in a way to embed the watermark. So it may take a little while, but this will not compromise with the accuracy and detection of the watermark, which will be recovered from the attack and watermark image. So here we go, and you can see that the status bar as it comes to an end, which indicates that the watermark is getting embedded in the image. So here we go, and this message indicates that the watermark is embedded into the host image. So I OK this. This is an option to see the watermark image. As you can see, I think this will give you a better option of actually viewing the two images in a larger scale. So these are the two images which you can see. This is the original image. This is the original image Lena, and this is the watermark image Lena. Perceptually, there seems to be pretty similar. There is no perceptual distortions that has come inside with the watermarking. So it indicates that the first condition of watermarking, that perceptual transparency is maintained, the watermark image looking very similar to the original image. Let's see the PSNR. So this option gives to calculate the PSNR. So the PSNR is 34.62, which is a good amount. It's a good number. 34.62 decibels PSNR is good enough, which indicates that the perceptual property is maintained. Let's see the normalized correlation to check the similarity between the original image and the watermark. It is 0.994. It's a fairly good number, which indicates that the perceptual quality or the quality of the watermark image is not tampered at all. So we can understand that the watermark image is as similar as the original image. This option gives you to check the payload conditions. So let's see how it goes. The payload seems to be 109.227 samples per bit. So it indicates that it's a demanding payload, and of course considerably good amount of good methods of watermarking should be chosen to to ensure that such demanding payloads are obtained. This module will give a choice, give an option to attack introduce an attack to the watermark. So let's say we go for median filtering attack, and I apply the attack on the signal. So here is the watermark signal, and the watermark signal is chosen, and a median filter attack is applied on the watermark image. So here we go. I OK this and show the attack image. So you can see that the watermark image is actually shown in this condition. So this is the attack image. So the attack image looks a little smoothened because of the median filtering. Now this is the option of the watermark extractor. So I click this option. So I'll try to recover the watermark from the attacked image. So here we go, and this status bar will indicate that the process is on, and once the process is done, it will indicate and pop a message that the watermark is extracted. So as you can see that this GUI is pretty user friendly, and it's not very difficult to use this graphical user interface. So here we go, the process is on, and the watermark extraction is under process. It takes a while in extracting the watermark because the operation is blockwise. The image is divided into blocks, and signal processing operations are carried out in each block, and sometimes it may take a while to extract the watermark. But then it ensures that the accuracy is not compromised, and the quality of the watermark, which is generated for actual identification, is not subject to any sort of compromise. So here we go, and you can see as the status bar comes to an end, the message will come up indicating that the watermark is done, the watermark extraction is done. I OK this. Now let's see the quality of the watermark that is generated. Let's say calculate the BR, the bit error rates. Here we go, and you can see that the bit error rate of this process is 0.177%, which is fairly good. So the watermark extracted is pretty accurate, and let's see the normalized correlation of the extracted watermark with the original watermark. Let's see how it goes. We can see that the normalized correlation of the extracted watermark with the original watermark is 0.99, which indicates that the watermark extracted is fairly high quality, and there won't be any much problem in actual identification of the template because of the good accuracy of extraction of the watermark. So the process seems to be pretty efficient in extracting an accurate watermark. Click this option. It takes some time for the processing part. You can see the status bar will indicate that the operation is under process, and the extracted watermark, which was extracted from the attacked image, is trying to get identified for similarity with some template in the database. Let's see how it goes. It takes some while. It takes a while, and the processing time actually depends on the size of the database in which the matching operation and the identification operation is performed. So we are actually performing this operation over a considerable amount of large database, and hence it takes some time to get the identification and matching of the extracted watermark with a sample in the database. So you can see the process is on. The process is on, and the status bar, as it moves towards the end, it indicates that it is trying to match and identify and with one of the sample in the database. The process takes a little while because of the size of the database in which the identification operation is done. So here we go, and process is on. Process is on, and it's taking a while because of the size of the database. So you can see the status bar is moving towards the end, and let's see. Well, you can see the message is displayed over here. That's 75% matched with the finger sample of 101.tif. Yes, the sample which was under here, you can see this is 101_1.tif, and it is actually matched with 101_tif, which indicates that there is a clear and distinct identification of the template. So this is the module in which the audio watermarking can be performed. So click this button. We can actually select one of the audio file. Let's say I take classical 2 as my sample. So classical 2 is loaded over here, and this button will give you the option of embedding the watermark. So the watermark is being embedded using the signal processing operations, and the status bar is indicating that the process is on. It takes a little while in embedding because the audio signal is divided into frame, and every frame is subjected to some signal processing attacks, and embedding watermark takes some time depending upon the size and sampling rate and quantization levels of the signal. So here we go, and you can see that the watermark is embedded. So the status bar indicates that it's fine, so it's done. So I OK this. So here I think there's an option of seeing the watermark. If I click this, show the audio watermark signal, so you can see that the audio watermark, this will give a better option of looking into the watermark into an enlarged form. So you can see over here, one is the original signal. Sorry. So this is the original signal, and this is the watermark signal. Perceptually, we can see there is no much distortion induced because of the watermarking, which indicates that the perceptual quality may be actually maintained. So here there are some more parameters. Let's say I calculate the signal to noise ratio. 27.37 dB is fairly good enough. Signal to noise ratio indicates that the perceptual properties are not tampered, because anything above 25 decibel is considered to be fairly good enough, which will not be audible to the human audio system. Let's calculate the normalized correlation between the original signal and the watermark signal, 0.999. So you can see the distortion that is produced because of the watermark embedding is fairly less significant and may not be perceptible to the human audio system. Now, what is a payload? Let's see. This option gives you to generate the payload and calculate the payload. 196 beat per second is the payload, which indicates that it's a high demand payload, and of course there has to be some good choice of methods to indicate that the watermark is properly done under this high payload condition. So achieving 196 bits per second really needs optimum choice of watermarking system. Press this option. So I need to select the watermark signal, and the attack is applied. So you can see the white Gaussian noise is added to the watermark signal. Now this we can see the attack signal. So this is the attack signal. I think it's pretty similar because only some Gaussian noise is applied, and this option will give you to extract the watermark. If I click this button, I need to recover the watermark from the attack signal. So attack signal, I have selected. This status bar is indicating that the process is on. Sometimes it takes a while to extract the watermark because the process is carried on in different frames of the audio signal. The audio signal is divided into frames, and the signal processing operations are carried out in each frame for extracting the watermark. And hence sometimes it may take a while to extract the watermark. And you can see as the watermark, as the status bar is moving along, the process is on. So here we go, and as the status bar is moving towards the end, we can see the extraction process is taking place. This process takes some time, but there is no compromise with the accuracy and of the extraction process, indicating that line completion will be proper. So here we go, and the watermark is extracted, the message is displayed. Let's see the quality of the watermark. The bit error rate of the extracted watermark with the original watermark seems to be 0.84, which is fairly good enough, and let's calculate the normalized CAD correlation of the extracted watermark with the original watermark. The normalized correlation seems to be 0.95, which is pretty decently good to have a unique identification. Now you can see there are some options. This option gives to play the host signal, this option to play the watermark signal. So I'm playing the watermark signal, which indicates that there is no much perceptual distortion brought in because of the watermark. For reference, I play the original signal, and you can see that there is no much difference between the original signal and the watermark signal, which indicates that the perceptual transparency is maintained.